In our previous video, we indicated that we would talk about advanced statistics from a correlational perspective, from a mean difference perspective, and then some other topics. Here's a brief discussion about correlational and regression statistical analyses. We'll start out with some that we've already presented and then briefly introduce some more advanced topics.
Here's a list of correlational statistics. We'll briefly describe each one of these. The thing to pay attention to is it's the number of independent variables and dependent variables and the levels of measurement of the x's and y's that discriminate between these. So we'll start with one that you already know about, the bivariate correlation, which is where you have two variables. The common statistic used here is the Pearson product moment correlation, little r. Notice it has one independent variable and one dependent variable. The second one you also know about. This is multiple regression, capital R. In multiple regression, you have multiple independent variables and one dependent variable.
With logistic regression, it's similar to multiple regression in that you have multiple independent variables and a single dependent variable.
Discriminant analysis is similar to logistic regression, except in this case you have multiple independent variables and multiple dependent variables.
Next, we have path analysis. We have one dependent measure and multiple independent measures. Essentially, path analysis is an attempt to look at the relationship amongst the various x variables, predictors, and how they relate collectively to the y or dependent variable.
Canonical correlation we've mentioned before, and this is when you have multiple independent variables and multiple dependent variables. You would look at the correlation between sets of variables, both independent and dependent.
Here we've indicated the number of x's and y's and how they relate to the various correlational procedures. Now let's take a look at the nature or the levels of measurement associated with each of these correlational procedures. So now, returning to bivariate, in the bivariate correlation, both variables, x and y, are continuous.
Meaning they have to be at an interval or ratio level of measurement. In multiple regression, the same thing is true. Both independent and dependent variables must be continuously measured.
With logistic regression, the outcome variable, y, is categorical. Importantly, there are only two levels. For example, alive or dead, diseased or not diseased, and then the predictor variables, x's, can be continuous or categorical in nature.
In discriminant analysis, the independent variables are either continuous or categorical. The dependent variable is categorical, but it can contain more than two levels.
Path analysis, both the x's and the y's are continuous variables, that is, intervally scaled or ratio.
In canonical correlation, the independent and dependent variables can be either continuous or categorical.
This figure summarizes all the different correlational procedures that we've talked about, the number of x's and y's, predictor and outcome variables, and the nature or levels of measurement associated with each one of those.